In this video, I'll be talking about the shooting method, which is the second way of solving differential equations by converting a boundary value problem to an initial value problem. So if you have a differential equation with two conditions on both sides, you're going to convert that problem into an initial value problem where we have conditions on one side. So in solving differential equations, we always have to have conditions on one side if we don't want to solve that through matrix operations. So last time we talked about direct method, where we converted all the boundary conditions and differential equation into a matrix form. And by solving all the equations simultaneously, then we satisfy both conditions. Now, if we don't want to use linear system to solve the differential equation or the nonlinear system to solve them, then the one way is to use shooting method, where we convert the two conditions on both sides into both conditions on one side. Alright, so to do that, first we have to set up the step size for the differential equation solver, which could be RK2, RK4, or Adam Moulton, or any method to solve the differential equation. We also have to set up a convergence for an error that we have to check when we do the shooting method, because shooting method makes a guess on one of the conditions, and then based on the guess value, it calculates, or it solves the differential equation. It checks the condition on the other side. If the condition is not met using the given value, then we have to basically come back and change the initial guess we made to solve the differential equation. So in a nutshell, the shooting method starts with setting up the problem as before. Let's say we have a domain from 0 to L. We split it into endpoints. Assume that we have conditions on the y, or on the function value on both sides. We have y0 on the left end, and we have, let's say, yn on the right end, like that. But because we don't want to, we cannot actually solve differential equation by having two conditions on both sides, we're going to assume that instead of y on the right end, we know dy dx, or the slope, on the left end. So now we have y and dy dx, or the function and the slope, both on the left end, instead of having y on the left end and another y on the right end. So that's how shooting method actually tries to make a guess on the slope to correct the difference on the function value that it calculates compared to that is given. Alright, so by making this guess, we can go and set up a function. We call it black box. So what we want to do with this black box is, this black box actually finds the error that we make between the calculated y value on the right end and the given value on the right end. This difference is going to be an error, and blackbox wants to make this error equal to 0 using f0 function in Matlab. Now, in blackbox, the way to calculate the y on the right end using the initial values, like the function and the slope on the left end, you have to use ODE45 or some sort of ODE solver. So in this ODE solver, we're going to have the differential equation set in this function, and then we have the x values, we have the initial condition, which actually is the function and the slope, and then some options for the tolerance. Then blackbox solves ODE, or using ODE45, it solves the differential equation. It finds the error between the function value on the right end and that is given to us. That is going to be the error, and then it tries to make that error using f0 function. After we make that error 0, then we have the exact dy dx, or the right slope on the left end. We're going to use this slope one more time with the function value on the left end to calculate, basically, or to solve the problem with the exact slope on the left end. Alright, so now I'm going to show you the Matlab script. Before doing that, I just want to touch base on the shooting function that I have in here. The shooting function is nothing but the problem statement or the differential equation written in a matrix form. So if our differential equation is the second order, we convert that second order to a first order system. And in this system, the first element is just y, the second element is the derivative of y with respect to x. So I think we did this before. If you multiply the first row of this matrix by the column here, then this is going to be 0, 1 times y and dy dx. You get dy dx, and dy dx is equal to dy dx on the left side. The second element here is the second derivative of y with respect to x, which is basically the rest. We have to convert the rest of the equation other than d squared y dx squared into an equation, and then write that into the last row of this matrix form of the differential equation. So now let's go back to the Matlab script and see how we can implement this in Matlab. Let's say the problem we want to solve is the second differential equation, d squared y dx squared plus 0.1 times y times dy dx equal to 0. Now to do this, in a domain of 0 to 5, then we set up the domain length equal to 5, number of points is 20 along the x. This is our interval. This is the x values from 0 to L in 20 points. We set up two tolerances. One is for convergence in F0 or the root finding, and then the second convergence or tolerance is for the ODE solver. We know that for ODE we have to also have a tolerance for the stopping condition. So this is how I set them up. Then the values that are given to us is the function value on the left end 100, function value on the right end is 0. But because I cannot use the function value on the right end, I want to make a guess on the slope on the left end. So now on the left end I have the function value exactly as it's given to me, and then the slope that I make a guess. Alright, so now what I do is I'm going to call this F0, which is a root finding function in Matlab, and I'm pretending that I have a black box that I want to find the root of. So what is the initial guess for this root finding? It's the slope that I just make a guess. Alright, so I guess the slope, and I want to find the zeroth of this function using F0 function. So what is in this black box? In this black box, with the initial condition dy dx, I construct a vector including the initial function value and then the initial slope that I guessed. Then I call ODE45 and feed in this initial condition into the function as the initial basically condition for ODE solver with the tolerance that I set up already up in the code. Now in this ODE45 I'm calling the function shooting boundary value problem, and this shooting boundary value problem is the matrix form of the differential equation. It has two elements. The first element is just y, and then the second element is dy dx. So if we convert the differential equation to a matrix form, then if you go back here, then dy dx is nothing but just, if you multiply this by that, you get dy dx equal to dy dx. So that means the first element in the dz dx is just the second element of z, which is dy dx. Alright, so I'm basically writing dz dx in this shooting function. And then the second element of the dz dx is basically the second derivative of y with respect to x, which according to the equation here, the second derivative of y with respect to x is negative 0.1 times 1 times y times dy dx, which is, based on this definition that I have here, the second element of the dz dx is going to be minus 0.1 times z1 times z2, because z1 is y and z2 is dy dx. All right, now I have my shooting function implemented. Then black box calls this function. It solves the differential equation. It comes with all y values, including the right end value. Then it subtracts the exact value on the right end with the one we just calculated. This difference is the error we are making. Then F0 wants to basically make this error 0 by calling the F0 function. So after F0 finds the exact slope on the left end, then we feed in that slope into OD45 one more time to basically resolve the problem as the final solution. So if I run this code, you see that it goes through 53 iterations to solve the problem. So this is basically the progression of the solution. Initially, we made a guess on the slope. So our guess was not really good initially. That's why we got this red curve. So Matlab solves basically the red curve, and it finds that the right end solution is 100. But we know that the right end solution should be 0, because that is the boundary condition given to us as a boundary value problem. So now we have to correct the initial slope such that the value of the function on the right end becomes 0. So that's how Matlab tries to change the slope, basically reduce the slope from what we gave before. Matlab tries to reduce that slope to something that is making the right end solution exactly equal to 0. So from red to blue, you see that how the function value on the right end goes down by changing the slope on the left end. And then finally it gets this below. And you see that sometimes the Matlab actually overshoots, so instead of basically monotonically reaches to the final solution, it may bypass the solution, gets this blue curve, which is now giving the right end value less than 0, which is not correct. So then Matlab actually tries to back out and then find the right solution, or find the right solution for the slope such that it gets the right end value equal to 0. And so now I'm replotting the solution again here as a red curve. So you see now I guessed the slope, but then F0 found the right slope for me. With that slope, if I solve the problem, you see that the function value is 0 on the right end. So to recap, we didn't actually use the condition on the right end initially. We used the initial value on the left end and guessed the initial slope on the left end. We corrected our guess, which is the slope, such that we get the right end solution exactly equal to 0. And this is how it's done in Matlab using F0 as a root finder plus OD45 to solve the differential equation. So the F0 basically tries to change dy dx, or the slope on the left end, such that it gives the 0 error between the exact solution, which is 0 on the right end, and what is guessed, where it's which is not 0 during the problem solving. All right, so I hope that is clear, and thank you so much for watching.